Alright guys, welcome back to Underground Science, and in this video we'll be practicing assigning oxidation numbers. Alright, so we'll just look at a few examples to get down the idea of how to assign oxidation numbers. But before we start, let's write out some rules. Alright, so some rules that we should be familiar with is that, actually no, before even that, let's go and pull up a picture of just a basic periodic table. And here we are. Alright, sweet. So pretty much the basic rule is that hydrogen, let's start with hydrogen. All right, so hydrogen is either going to be in a +1 oxidation state. So it's either going to be a +1 oxidation state, especially with nonmetals. All right, so nonmetals, remember this whole line starting from here goes all the way down, separates the transition metals from the nonmetals. All right, so all of this right here from this line on, all of these are nonmetals, right? Some of these are metalloids, but in general, these are all nonmetals. All right, so hydrogen with nonmetals is usually going to be a +1 oxidation number, but hydrogen with metals, so like for example, all these transition metals, right? In general, hydrogen is going to be a -1 oxidation number. It's going to have a -1 oxidation number with metals, generally. All right, so -1 with metals. All right, so that's that, right? And then so next we have to look at the groups in general. Okay, so the first group, right, group 1A and 2A is going to ascend like +1 and +2. Okay, so in general, group 1A will have a +1 oxidation number, and group 2A will have a +2 oxidation number. All right, and one thing to know is that usually, like an element like fluorine will have a pretty much an oxidation number of -1. All right, usually. And let's see, what else should we get down before starting the video? So we just said that these were all nonmetals. And oxygen, let's do oxygen. So oxygen will usually have an oxidation number of -2, except we'll see in some cases where there's more than one oxygen atom in a compound like hydrogen peroxide. In that case, we'll have an exception of a -1 oxidation number. We'll look more into that, all right? So I think this is enough to get us started, right? And so let's go and try to work out our first example, right? Our classic water, all right? So water will be our first example. So let's go ahead and actually, sorry about that, let's go ahead and scroll down more since we have more room. And let's go and write down water. All right, so let's go ahead and start. So let's scroll back up and look at hydrogen. So here we see with nonmetals, hydrogen's usually going to have a +1 oxidation number, and with metals, hydrogen's usually going to have a -1 oxidation number. Well, oxygen, right, is bound to the hydrogens, is a nonmetal. So this tells us that hydrogen in this case is going to have a +1 oxidation number. So let's go and write that down. So right now, this is the video, right? So we're assigning oxidation numbers. So the oxidation number for hydrogen in this case, since it's bound to oxygen, which is going to be a nonmetal, is going to be +1. Oxygen, however, we said is going to be usually -2 or -2. Oxygen has an oxidation number of -2, and we'll see an exception later. But in this case, this is not an exception. Oxygen by itself, only one atom of oxygen. So we're going to have a -2 oxidation number, all right? And remember, because we have no net charge here, right? We don't see any charge here like a minus or a plus, right? We don't see anything like that. That means that H2O is neutral. So we need the oxidation numbers to add up to be 0, representing the neutrality of water. So you might be thinking, all right, well, 1 minus 2 does not equal 0. Like, okay. But remember, we have to multiply +1 by 2 because we have 2 atoms of hydrogen. So if you do that, you're going to get +2. Then if you subtract -2, we're going to get 0. All right, so we're good. So we have correctly assigned oxidation numbers for the elements of water. All right, so let's look at another example. So this example is going to be hydrogen peroxide. All right, so hydrogen peroxide. Here again, Hydrogen is bound to a nonmetal, which is oxygen, so we're going to expect a +1 oxidation number. All right, so that's that. But here, we don't have an oxidation state of -2 for oxygen. Now, why is this? Because we're in a peroxide, and this is the exception. When oxygen is part of a peroxide, we're going to have a -1 formal charge, or a -1 oxidation state. All right, and okay, you know what? Let's just go ahead and see why we shouldn't write -2 here. Because hydrogen is either going to be +1 or -1, right? In this case, it's +1. If you say -2 for oxygen, and here we see hydrogen peroxide is a neutral atom, a neutral compound as a whole. So we know that the oxidation numbers have to add up to 0. If you put -2 for oxygen, -2 times the 2 atoms of oxygen is going to equal a -4 total oxidation state for both our oxygens. Hydrogen, same thing, times 2 is going to equal +2. If you do +2 minus 4, we're going to get an oxidation state of the whole compound as -2. But we don't have a negative formal charge or negative net charge, you could say, on the whole compound. This compound is neutral. This value has to be 0, not -2. So that's why in a peroxide, we can't put an oxidation number of -2 for oxygen. It has to be -1. That's an exception, okay? So this is the exception for oxygen. -1 oxidation number in hydrogen peroxide. Okay, so now if you do this, now if you go and multiply by 2 atoms of oxygen, you're going to get -2. And then now you can go ahead and subtract +2 and -2, we get 0. And that's good. That tells us we have no net formal charge on this whole compound, and we don't. It's neutral, right? So hydrogen peroxide is neutral. This is our exception, right? So let's go and look at another example. All right, so let's go and clear this page up, and let's go and pull up our periodic table again. All right, there you go. Now let's go and look at carbon dioxide, I guess. All right. So carbon, okay, that's an ugly O. Carbon dioxide, right? 2 oxygens, 1 carbon, and we're familiar with this, right? This compound. All right, so let's start by our familiar one, which is oxygen. So we know oxygen is usually -2 with the formal charge, or with an oxidation number of -2, right? So we're going to write a -2 oxidation number here. Now, we know, again, CO2, guys, is nonpolar, and we know it has a net, we don't see any net charge here, right? So CO2 is a neutral atom. That means that our oxidation numbers of every atom here has to equal 0 when we add it up. Knowing that, we can kind of set up an equation in your mind, right? So we know that we have 2 atoms of oxygen. So for oxygen, we have a -2 times 2. So we have a -4 charge of oxygen, okay? Now we need to add, remember we're adding the oxidation state of carbon. So it's going to be some random oxidation state that we're trying to figure out, but we know that as a whole, as carbon dioxide as a whole, it's neutral. So we're going to have a total sum of our oxidation numbers as 0. So if we just solve for x, we can see that x will equal +4. And so that's our oxidation number for carbon, +4. You can even go and test that out. Just multiply -2 times 2 for oxygens, oxidation total, oxidation state, which is -4. Then +4 minus 4 equals 0. And that's what we want because CO2 doesn't have any net negative charge or net positive charge. It's neutral. Okay, so it has to equal 0. Our oxidation numbers of every element has to equal 0. All right, so that's CO2. So as you can see, it's just a step-by-step process, and once you get the hang of it, it's not that hard, okay? So we can keep on working together and get better at this. So let's look at another example, all right? Oxygen, diatomic oxygen. Now this is another rule that I don't think I stated, but any element that's in its elemental form, like diatomic oxygen or diatomic fluorine or anything like that, okay? And just one element by itself in elemental form, no matter what, will have an oxidation number of 0. All right, so that's easy for this problem. So oxygen will have an oxidation number of 0. All right, because it's in its elemental form. Okay, so let's look at next. Let's look at potassium permanganate. All right, so let's go and write that down. Potassium permanganate. All right. So potassium permanganate, we can start by recognizing the familiar things, okay? So, actually first, keep in mind now that we have a net zero charge still, because you would think we have a net negative charge, but this negative charge and this positive charge pretty much balance out. So sorry that I wrote it like this. It gets kind of confusing. Let's just write it like it is. Potassium permanganate, all right? So this is still a neutral atom. So we're going to have, so remember, actually, you know what? Let's go to our previous thing and let's look at one important rule, right? Here we said that usually, so this is our first column in our periodic table, our group 1A will usually have a positive 1 oxidation state, and our second column in our periodic table, or group 2A, will usually have a positive 2. We're working potassium permanganate, right? So that's in group 1 like we see here, which means that potassium will have a +1 oxidation number. Let's go and assign that right away, help our lives out a little, all right? So +1 for potassium. All right, sweet. Let's see, oxygen we know has a -2 oxidation state, right? It's not a peroxide, so we don't have to worry about that exception, right? Will have a -2. Now, again, it's an equation. You can work it like an equation. We know that the oxidation numbers, if you add it up, has to equal 0, right? Because there's no, potassium permanganate is neutral. There's no net charge that we see here. So if we do that, all we're trying to solve for now is the oxidation number of manganese. So all we have to do is do this. +1, right? +1, oops, sorry about that. +1 -2, but this -2 is technically times, so let me do this, times 4, and then you have to add some oxidation number to equal 0. So we're going to add some x number of oxidation, right? Oxidation number, and we're going to equal 0 because we don't see any net charges, so we have a neutral atom of 0. So if we go and solve this out, you're going to get +1 minus 8 plus x equals 0. +1 minus 8 is -7. So let's go and write that in a whole different color. -7 plus x equals 0. X equals +7. All right, so that's your oxidation number for manganese, +7. Now you can go and check this by actually adding each one up and seeing if it equals 0. So +1 plus 7 minus 2, but this is -2, oops, sorry. This is -2 times 4, which is -8. So -8. So +1, or 1 plus 7, right, is 8. So we're going to write 8 here, and then 8 minus 8 is 0. So we're good, right? We have successfully assigned oxidation numbers to potassium permanganate. Now let's go and look at one more example, and that example is now going to have a net charge on it, so we have to be careful for that. Alright guys, so our last and final example we're going to look at is going to be our sulfate ion. Alright, so our sulfate ion. Okay, so just before we start, let me pull up the periodic table again. Alright, sweet, here we are. So let's go and do our last and final example. Let's put oxidation numbers, let's assign oxidation numbers to sulfate. Alright, so sulfate is SO4 2-. Alright, so right off the bat, we need to acknowledge that whatever oxidation numbers we end up assigning, if we add those oxidation numbers up, we have to get -2 as our summation, like when we sum it up or end up subtracting it. Okay, so when we add the oxidation number for sulfur and add the oxidation number for all 4 of the oxygens, when we add that up, it has to equal -2 because that's the net negative charge for sulfate. So let's go ahead and do that. So if we go ahead and locate oxygen, right? Remember, oxygen usually has a -2 charge, -2 oxidation number. All right, guys. So oxidation number for oxygen would be -2. So if the oxidation number for oxygen is -2, and we have 4 oxygens here, so -2 times 4 is going to be a -8. So -8 is our total oxidation number for all 4 atoms of oxygen. We know that the oxidation number now, sorry about that, the oxidation number now for sulfur has to equal, or if you add -8 to the oxidation number of sulfur, has to equal 2-. So the way we do that is just set up an equation. So -8 right? And let me go and stay consistent with the colors. Sorry about that. So -8 plus I don't know what, right? Right now is equal to 2 minus. That's our negative charge that we have to equal. I don't know why I'm writing it like that. Just do -2. Now we just solve for x and we get +6. So the oxidation number for sulfur should be +6. And we can go and check that out by actually adding the oxidation numbers, right, times its number of atoms it has, and we have to see if it equals -2 or not. So 6 plus -2 times 4, which is -8. So 6 plus a -8 is pretty much 6 minus 8, which is -2, and that is our net negative charge on our sulfate polyatomic ion. All right, so that was assigning oxidation numbers for you guys. I really hope this video made sense, and I really hope to see you guys here, right, in my future videos where I'll talk about more cool topics about biochem, chem, and physics. And so let's keep on learning science every day here at Underground Science, and see you guys next time. And make sure to like and subscribe and hit that notification bell, and stay safe.